Hello friends, my name is Piyush. Today I am going to share multiplication of matrix in this video. Actually, we have three main operations with the matrix: addition, subtraction and multiplication. Addition and subtraction are very easy to calculate, but most of the students have problem in multiplication. So in this video I am going to show that how can we do matrix multiplication with the property that what will be the order of the resultant matrix. So let's see this video.
So welcome to my video on matrix multiplication. And before I get started with this example, I want to talk about the sizes of each matrix, because not every matrix can be multiplied by another matrix. So let's take a look at the size of this first matrix. In this first matrix we have 2 rows, and we have 2, 3 columns. So this first matrix is a 2 by 3 matrix. 2 rows by 3 columns. And if we take a look at the second matrix we're multiplying, we have 1, 2, 3 rows, and we have 1, 2, 3 columns. So this second matrix is a 3 by 3 matrix. So in order to multiply two matrices together, the columns in the first matrix must equal the rows in the second matrix. So in other words, these two inside numbers must be the same. So it's really important to check this before you multiply matrices. If these two inside numbers are not the same, you cannot multiply the two matrices. So after you make sure that your inside numbers are the same, then you can take a look at your outside numbers, and I'll draw some arrows to point to the outside numbers. And the outside numbers will always give you the size of the new matrix after you're done multiplying. So since the outside numbers are a 2 and a 3, we know the size of the new matrix after we're done multiplying is going to be a 2 by 3 matrix. So let's just get started right away with this example. So basically what we're doing when we multiply two matrices is we're multiplying the rows of the first matrix by the columns of the second matrix. So I'm going to put a box around the first row of the first matrix, and I'm going to put another box around the first column of the second matrix. And just to make things a little easier to see when we multiply, I'm going to circle the first number in the row in green, and I'm going to circle the first number in the column in green, and I'm going to circle the second number in the row in black, and I'm going to circle the second number in the column in black, and I'm going to circle the third number in the row in red, and I'm going to circle also the third number in the column in red. So now when we multiply the first row by the first column, we can multiply the green numbers together, which is 2 times 3. 2 times 3 is 6. Then we can multiply the black numbers together, 3 times 1, which is just positive 3. And we can multiply the red numbers together. 1 times 2 is just positive 2. So now we have multiplied the first row by the first column. And now I want to do the exact same thing with the first row and the second column. And the first row is still boxed from earlier, and I'll put another box around the second column. And once again, I'm going to circle the first number in green, the second number in black, and the third number in red. And if we multiply the green numbers together, we get 2 times 4, which is 8. If we multiply the black numbers together, we get 3 times 1, which is just positive 3. If we multiply the red numbers together, we get 1 times 1, which is just positive 1. And now we have multiplied the first row by the second column. And now I'm going to do the same thing all over again. Now I'm going to do the first row by the third column. The first row is already boxed from before, and I'll put a box around the third column. Once again, I'm going to circle the first numbers in green, the second numbers in black, and the third number is in red. And if we multiply the green numbers, we get 2 times 5, which is just 10. And if we multiply the black numbers, we get 3 times 4, which is just positive 12. And if we multiply the red numbers, we get 1 times 4, which is just positive 4. So now we have multiplied row 1 of the first matrix by every single column of the second matrix. So now we need to do the exact same thing with the second row of the first matrix. So I'll put a box around the second row. And we need to multiply that second row with every column of the second matrix. So I'm going to start with the first column, and I'll put a box around it. And once again, I'm going to circle the first numbers in green, the second numbers in black, and the third numbers in red. And if we multiply the green numbers together, we have 2 times 3, which gives us a positive 6. And if we multiply the black numbers together, we have negative 7 times 1, which is just negative 7. And if we multiply the red numbers together, we have 4 times 2, which is positive 8. So now we have multiplied the second row by the first column. And now we need to do the exact same thing with the second column. So I'm going to put a box around the second column. Once again, circle the first number in green, the second number in black, and the third number in red. If we multiply the green numbers together, we have 2 times 4, which is positive 8. And if we multiply the black numbers together, we have negative 7 times 1, which is just negative 7. And if we multiply the red numbers together, we have 4 times 1, which is just positive 4. So now we have multiplied the second row by the second column. And now we have to do it one last time. We need to multiply the second row by the third column. So I'll put a box around the third column. Once again, the first number in green, the second number in black, and the third number in red. If we multiply the green numbers together, we have 2 times 5, which is positive 10. If we multiply the black numbers together, we have negative 7 times positive 4, which is negative 28. And if we multiply the red numbers together, we have 4 times 4, which is positive 16. So as you can see, these problems can get pretty long and tedious. But now we have multiplied every row from the first matrix with every column from the second matrix. So now the only thing we have left to do is just simplify this matrix and add all these numbers together. In the top left corner, we have 6 plus 3 plus 2, which is 11. In the bottom left corner, we have 6 minus 7, which is negative 1. Negative 1 plus 8 is positive 7. And in the second column, we have 8 plus 3, which is 11. 11 plus 1 is 12. And we also have 8 minus 7, which is positive 1. 1 plus 4 is equal to 5. And in the top right, we have 10 plus 12, which is 22. 22 plus 4 is equal to 26. And in the bottom right, we have 10 minus 28, which is negative 18. Negative 18 plus 16 is equal to negative 2. And this is our final answer. We have completely multiplied these two matrices together.